Okay, so in this video we're going to do what looks like a pretty simple integral, but it's a lot less intuitive than someone actually might think. So before we start, let's just manipulate this a little bit. This is the same thing as the integral of secant theta times, or secant of x, sorry, times secant of x plus tangent of x. I don't like that line. Secant x times tangent x divided by secant x plus tangent x dx. And I didn't change anything right here. I just multiplied the top and bottom. I just multiplied by 1, basically, because these cancel out and you'll back at secant x again. So now we can put this even further. That's the same thing as the integral. I'm just distributing into the top. You're going to get secant squared of x plus secant x tangent x divided by secant x plus tangent x dx. Now we can make, actually what we can do now is we can use substitution. So, because you can kind of see it right here, we have tangent, and we have its derivative, secant squared of x, and then we have secant x, and we have its derivative, secant x tangent x. So let's make a u substitution. Let's say let u be equal to, I'm going to move it over to the, let u be equal to secant x plus tangent x. So if u is equal to that, then we know that d over the derivative of u with respect to x is, I'm going to flip these again. So the derivative of tangent is secant squared of x, and then the derivative of secant is secant x tangent x. So yeah, nothing complicated here. I just took the derivatives. But now what we can do is, since this is technically it's a differential, we can multiply it. We can multiply the dx. We can multiply both sides by dx. So when this happens, that's the same thing as we can multiply both sides by dx. So in this case, the dx's cancel out, and then you get equals secant squared of x plus secant x tangent x dx. Now what we can do, we have terms for du, we have terms for u and du. So now we can substitute this in, and I'll write it. I'll do it in like an orangey color. So the integral of what we have right here, that's the same thing as the du term. I mean, this is technically just being multiplied by dx. So we have a du term. We can substitute in du at the top, and then we let u be equal to secant x plus tangent x. So we can make a substitution on the bottom too. And that's a very simple integral. That is the natural log of the absolute value of u plus c. But since we started in terms of x, we should definitely substitute back in for u. So we can do, so now we have the natural log of secant x plus tangent x, the natural log of the absolute value of that plus c, and that equals the integral of secant x.